Hello everyone, welcome back to our solving session. My name is Shabani Mchomv. Today we are going to see problems on coordinate geometry, or we call it the conic sections. These conic sections involving the parabola, hyperbola, and the ellipse. Now the question that appeared in Advanced Mathematics Paper 2, ACSE in the year 2025, it was question number 8 according to the format, and it consisted of 6 parts, A, B, C, D, and sorry, here it is, E. So the 5 parts, as you can see. Now starting with case A here, let's see the solution scheme for it. An equilateral triangle is inscribed in a parabola y square equals to 4ax, whose vertex is at the vertex of the parabola. Now it means now this equilateral triangle is within the parabola, the conic section parabola, and one of the vertex of that equilateral triangle is at exactly the vertex of the what? Of the parabola. And then now we are required to find the length of the side of the triangle. As we know, the property of equilateral triangle, that's the lengths of all the sides are equal in size. They are equal in magnitude, but also all the angles that are found, the interior angle that are in the equilateral triangle, all of them are equal in size. It means they are 60, 60, 60 degrees. So if that to be the case, and the parabola that we are provided here, it is y square equals to 4ax. It means that is a parabola where the vertex of the parabola is at the origin, is at 0, 0. Yeah, if the parabola happened to be like that format. But otherwise, it is translated in parabola. But this one, it is a parabola at the origin. And now maybe we design, maybe we can say now, given the conic section parabola for AX, that is parabola, our conic section. And we are provided with a equilateral triangle. So if we design a diagram now, here, if we draw the XY plane, so that is XY plane. And now, this is a parabola y square equals to 4ax. This way. And now we assume here will be our directrix line. It is always back to the vertex. So the vertex is here at the origin, 0, 0. Yes. And this now will be the directrix line. The directrix line that x equals to negative a. And then now, if that to be the case, so here we have the foci, but for parabola, this is not necessary because we are told the triangle, equilateral triangle, is inscribed in that parabola, so we can design. So this is our equilateral triangle here, and we join the third part to be a closed figure. Yes, so it has to be like that. Equilateral triangle means all the sides look the same in magnitude. So it means if maybe here it is point P and here is Q, it means VP the same as the length of VQ, the same as the length of PQ. So that is equilateral triangle VPQ. And now we can choose this variable point here to be in parametric point of the parabola. So a simplification can be simple. So here we have 80 square, 280. And here parametric point for this will be 80 square, negative 280, because here we are at the negative side of the y-axis. So it has to be like that. Now we are told you to find the length of a side, the length of a side. So a side either VP, either VQ or PQ, because these are the only sides of that equilateral triangle. Maybe you can write here sides of equilateral triangle. Equilateral triangle. Equilateral triangle VPQ. So the sides are, so we have VP, we have VQ, and the PQ. It means for the equilateral triangle, VP equals to VQ in length equals to PQ in length. So if that to be the case, it means now we need to know the length for this side because we have the points, we can apply the distance formula in coordinate geometry, so as we can know the size or the length of one side and the another. Yes, if that to be the case, starting with VP, so in distance formula now, so VP, we take the point, that is 80 square minus, that is x2 minus x1, which is 0, bracket square. Then we plus again, that is 280 minus 0, then square. So here we are going to end up getting, will be here 80 square, and the minus this remains 80. So here will be a square, then t raised to 4. Now we plus again, this one will be squaring this part here. So it is going to be 4a square, then t square. So that will be VP. Now VQ will be equals to what? So we just check here, VQ. So we take 80 square minus 0, x2 minus x1. So square, we plus again, that will be negative 280 minus 0, then bracket square. So this is less more to say. Here will remain 80 square, then squared. So will be a square, t raised to 4. Then now we plus, negative will cancel out because of the square. So here remains 4a square, then t square. So it looks like the VP. So VP is the same as VQ. But what for the PQ? What will be the length for PQ? Now here we involve these parametric points. That's 80 square, we minus again 80 square, squared, now we plus, then negative 280 minus 280, so squared. So this becomes 0, but here it will be negative 4 if we square it. So here we will take out the roots of, here will be negative 4at bracket square. So now we end up getting, here will be, and that's if we categorize this negative here, will be negative 1 square, then 480 bracket square. So it will be something like this. So this will be 1 positive. It means now PQ is less more to say it is 480. So 480 is what now we are going to get. Yeah. And mind you that no length that is supposed to be negative. All lengths we consider they are positive. So if that to be the case, now we compare, because for the concept of equilateral triangle, it means the lengths of the side are equal. So now we say for equilateral triangle, VPQ, it means the length VP the same as VQ is the same as PQ. So these lengths will be the same. Now, since VP and VQ look the same, now we compare with this PQ. So we say PQ, it is 480, now equals to what? Equals to the root, the square root of a square t raised to 4, then we plus 4a square, then t square. So equal to that point. Now on squaring both sides here, on squaring both sides, then we have, what exactly do we have here? If you square here now, you'll have 16a squared then t squared equals to a squared t squared 2e raised to 4 with plus 4a squared then t squared. So something like that. So if that to be the case, now we can operate like terms. As you can see here, 16a squared t squared and this 4a squared t squared. Now we just assign them to one side. So this come, then it'll be 16a squared t squared. Subtract this 4a squared t squared equals to a squared t raised to 4. Now from here, when you're operating by subtracting here, you'll end up getting 12 a squared t squared is less more to a squared t raised to 4. If we simplify by dividing with a squared t squared to every term, here we are going to end up getting 12 equals to t squared. So now the value of t will be equals to the square root of 12. So plus or minus. So here t is less more to plus or minus. If you simplify here, you get 2 then the root of 3. So we get t equals to the root of 3. Now from this point of view, because we are told that we need the length of a side, we are not guided that it is VP is needed or PQ is needed or VQ is needed, the length of a side. So you can just go back to these VP, VQ, and PQ. We choose one of them, then we substitute the value of T. So now here, for example, you can choose PQ. If you choose PQ there, so we can say now from PQ is among the lengths of that equilateral triangle. That is less more to 4AT. But now T equals to what? Remember length, we take it as positive unit. So there it is 2 the root of 3. So that's negative, we just ignore it because we are dealing with length. The dimension that is always positive in unit. So here, if that be the case now, PQ is less more to 4a bracket. Now t is 2 the root of 3. So we end up getting PQ equals to 8a then the root of 3. So here now it is what? We say this will be the length of that equilateral triangle. So therefore, the length of the side of the triangle is 8a the root of 3 units. So that will be now the answer. Now, having said that, now we are through with part A. Now let's see the solution scheme for part B. So case B here. In case B, we are told if two tangent lines to the ellipse 9x squared with plus 4y squared equals to 36 intersecting. So here we are provided with the equation of an ellipse given the ellipse that is 9x squared with plus 4y squared equals to 36 intersecting the y-axis at the point. So at the point this much. So that means y-intercept. So the y-intercept here, it is the point P 0, 6. Now find the point of tangents. So the point of tangents. The point of tangents, it means is the point of contact between the tangent line and the conic section, the ellipse. Where do they meet? So where tangent line and the ellipse meets at that one point, then that one point is what we call the point of tangents or the point of contact. So this is what now is required. And here it means we have two tangents line. So we are supposed to find the point of tangents. They're supposed to be 2. Now, if that to be the case, now let's see how we can solve this problem. So if we refer the general equation of tangent to the ellipse that is given by solution, the general equation of tangent to the ellipse, the conic ellipse, it is given by y equals to mx plus or minus the root of a square m square, then we plus b square. So that is the general equation of the tangent to the ellipse. So if that to be the case, we need to know what is a, what is constant b, and this y and x are provided because, very fortunate, we are provided with the y-intercept. We are told that these tangent lines intersect the y-axis at the point P, that is 0,6. So if that to be the case, so this will represent the x and y from there. It means there what is missing is m. M, we take it as the slope. So this m here, we know it is a what? M, the slope. And if that to be the case, and now we can say x comma y, we consider the point of intersection 0,6. And then now from the equation of that ellipse, 9x squared with plus 4y squared equals to 36. This can help us to obtain the constant a and the b. So we can express this in its format like we divide by this constant here at every term. So if we divide by 36, both sides of this equation of an ellipse, now we end up getting, if we divide by 36, here will be x squared over 4, we plus y squared over 6, now equals to what? Equals to 1. So from here, if we go and comparing with the general form, that is x squared over a squared plus y squared over b squared equals to 1, it means now a squared equals to 4. That means a equals to 2. And b squared equals to 6. Here we get 9. Sorry, here is 9. Because 4, when you try to divide 36 by 4, we get 9. So b squared equals to 9. That means b equals to 3. It means here b is greater than a. If b is greater than a, according to the property of conic section in ellipse, it means the major axis is along the y-axis. The major axis is along the y-axis. So if you try to design this diagram, here will be like this is just an ellipse, and now these are the tangent lines. So these are the tangent lines. So tangent line 1, this is tangent line 2. As you can see here where they touch, so this is the point of tangents, maybe you can say Q, and this is Q dash. So these were the points of tangents to the ellipse. And here, if this is y-axis and here is x-axis, it means this is the point of intersection of the two tangent lines on the y-axis, that is point P 0,6, as we were given earlier. So what is needed is this Q and the Q prime. Where are the tangent points? So if that to be the case now, so we proceed. So we proceed and say now, if all now are known that a and b and the x and y now, we can go to the general equation of tangent to the ellipse. That is y equals to mx with plus or minus, then a square times m square with plus b square. So y 0,6, you say here is 6. So 6 equals to here will be 0 plus or minus. Then now a, our a there is 2, so it will be 4 m square with plus b square, we know it will be 9. So from here we have 6 equals to plus or minus 4m square with plus 9. Now from here we can just formulate 6 equals to the roots 4m square plus 9, or 6 equals to negative then 4m square with plus 9. So on squaring both sides, on squaring both sides, yeah, then we have, so what exactly do we have? If we square here, we look the same as this one because this is a matter of the what? The length. We are dealing with the tangent line, which always its unit in length will be positive. So we get the same expression or the same equation. So if we square, we get here 36, and then now equals to 4m square here with plus 9. So we can just try to operate in the same terms. So the 6, this 9 will go to the other side. So we subtract 9 equals to 4m squared. So up to that point, now we can operate here and getting 27. So here will be 27 equals to 4m squared. So from there, we are in need of m. Remember, m, we said it is a what? A slope that we are in need of. So if we divide now by 4 both sides, we end up getting m squared equals to 27 now over 4. Now on square rooting both sides, here we are going to have, sorry, so this one, then plus or minus. So we get m equals to plus or minus, here it is plus or minus, the roots here, because they share the same index, it means the same as categorizing them as like this. So here we end up getting 3 times 3 times 3, it means now it will be 3 root of 3, then here will be 2. So it will be 3, the root of 3, then over 2. That will be our slope for that tangent lines, because the lines here, the tangent line are 2. So one for positive and the other one for negative. Now, if we go now with the help of parametric points, a parametric concept in the concept of ellipse, that's where now it can help us to obtain these points of tangents. So if we move and say now, from the parametric points, for ellipse, that is xc is less small to a, the cosine of theta, and the y is less small to b, sine of theta. Now we try here to use parametric points to formulate the slope through derivative concept. So if we formulate the slope through derivative, let's see what we have. We are still in a good track to reach the final stage. So here, for x equals to a cos of theta, now let's find the dx d theta through the application of differentiation. Now dx d theta here will be negative a sine of theta, and y equals to b sine of theta. This is another parametric point. So dy d theta equals to what? Dy d theta will be b cosine of theta, because differentiation sign we get positive cosine. Now from there, we know slope equals to dy dx. So through these parametric points, we can find dy dx by the chain rule. So we say now dy dx equals to, it's a dy d theta. Now we times this dx d theta, it's reciprocal. So we introduce -1 here. So at the end of the day here, dy d theta, it is b cos of theta. It means now we times dx d theta will be negative this, so it will be 1 over negative a sine of theta, because here we are reciprocating it. So if that to be the case, now it will be negative b over a brackets, then the cosine of theta over the sine of theta. But this is what? Here will be negative b over a, cos over sine, we know it is cot of theta. So from there, what is the value of b and a? If we remember, b were The value of B was 3, and the value of A was 2. So if you plug them here, you are going to have negative 3 over 2, then cot of theta. Because here B, we know it is 3, and the A equals to 2. From that equation of an ellipse, if you find that A and the B. Now, if that to be the case, here we can simplify more, and we know cot of theta is the same as tangent of theta, 1 over tangent of theta. So if we introduce that one, it means here dy dx, here we'll have negative 3 over 2 cot of theta. We know we can just end up to that point first, then we will see how we proceed. Now, if this is the slope, now we compare with that slope here. So we just compare it. So now taking that m equals to the dy dx. As you know, slope of the tangent line at the point of tangents equals to the slope of that curve, of that conic section ellipse. So it'll be the same. So this concerns the slope of the ellipse at parametric points, whereby we know those parametric points as variable points. Now it means we assume like the point of tangents where the tangent line touches the ellipse. So if that to be the case, this now will be the slope for the ellipse, and this m here will be the slope for the tangent line, because you obtain it from all the way through from the general equation of tangent to the ellipse. So if that to be the case, it means these two slopes now will be the same. So if that to be the fact, now we can say positive or minus 3, the root of 3 over 2 is less more or equals to negative 3 over 2 cot of theta, the cot of theta, this dy dx. So this is m here, and this one, it is the slope of the ellipse, that is negative 3 over 2 cot of theta. So if we try to simplify, the 3 over 2 cancel out. Now we remain with positive or minus the root of 3 equals to negative cot of theta. So now you can categorize and say radical 3 equals to negative cot of theta, and or we say, or negative root, square root of 3 equals to negative cot of theta. So if you want to have one value, now if simplify, then cot of theta equals to negative root of 3, or cot of theta equals to root of 3. Yes, if that will be the case. Now, in our scientific calculator here, we don't have the cot inverse trigonometric function for the tangents. We have only these tan, sine, and tangent. So we can express this cot of theta in terms of tangent, and we know it's reciprocal. That the reciprocal of tangents is this much. So here it's the same as say 1 over tan of theta is less more to the root of 3, or 1 over tan of theta is less more to the root of 3. Now, on making subject tan of theta, we end up getting negative 1 over root of 3. So if you rationalize, we get negative root of 3 over 3. So here we are going to have negative root of 3 over 3 here, or tan of theta equals to the root of 3 over 3, positive, because this is positive case. And now we can use now our scientific calculator here to find the angles, tan inverse for those values. All right, shift now tan inverse brackets negative, radical 3, then bracket. So negative 30 degree, because we know tangent is positive around the first quadrant and the third quadrant. So If it drops to the second quadrant, yeah, here if we change this, because here we get negative 30, so if you add it with 180 degree to have a positive angle, it means our theta here equals to this tan inverse of negative root of 3 over 3, which is the same as 150 degree. So it's the same as 150 degree, or theta equals to the tan inverse of that root of 3 over 3. That end up getting what? So we say shift tan inverse, the roots of 3. So in positive case, here it will be 30 degrees. And if you want to know it is true, maybe we find tan of 150 degree. Yeah, we get negative radical 3 over 3, but also tan of 30, we get positive radical 3 over 3. So that means, yeah, we're right. So from there, if that to be the case, we go back to those parametric points on the ellipse here. So because we have number of degrees here, we can have this x and the y, where we can formulate the ordered pair or the coordinates of the points of tangents, that is x comma y, on the ellipse. So now we go finding the Cartesian points in terms of x and y by introducing the values of theta in those parametric equations of the ellipse, parametric points. So from x equals to a cosine of theta, which is the same as a we know it is 2, then cos of theta. It means now x equals to 2 cos of theta. Now we say for theta equals to 150 degrees. Now what will be the value of x? And for theta equals to 30 degrees, now what will be the values of what? The value of x. Also, from y equals to b sine of theta, which is less more to b, we remember b was 3. So the value of b was 3 sine of theta. It means I have y equals to 3 sine of theta. Now, for theta equals to 150 degree, what will be the value of y? And for theta equals to 30 degrees, what exactly will be the value of y? From here now we can formulate now the points. So let's see. So here we have 2, then we say cos 2 cosine of maybe x, then calculate. So if it is 150, so for 150 we get negative 1 point, we approximate 1 decimal place. Then for 30, we get a positive 1.7. So it means here you'll have one coordinate for x. And now if we move and say now if we clear the data through our scientific calculator, now we insert this y equals to 3 sine of theta. So 3 sine of theta x here, calculate. When theta it is 150, so we plug there, what will be result? So here will be 1.5 units. And when it is 30 degree, we get the same 1.5. So now we come and say now the point of tangents, the points of tangents are, so we start. For 150 degree, we just check here for x coordinate that was produced was negative 1.7, comma, and here 150, what did we get for the values of y? 1.5. So that is 0.1 for tangents, maybe for one tangent line. And the other one, so we just come here. When it is 30, we get 1.7 x, and the y, we get the same thing, 1.5. So here we consider that these two now will be the point of tangent. So this will be for tangent 1 that touches the cycle, and this for the other tangents that touches that ellipse. Sorry, not a cycle, that conic section ellipse. Yeah, so these were the required points of tangents. And up to that point, we have answered part B. Now let's see part C. Let's see part C. Okay. Now in part C, find the equation of a cycle which passes through the points A, B, and C. Write the equation in the form of this. This is the standard form, yeah, of the cycle, where F, G, and C are constant. Are constant. So if that to be the case, if all these points passes through with the circle now equation in this, and if now these points belong to this circle, it means the circle is passed through them. It means these points satisfy the equation of a cycle. So we start with that idea from there. It means every point should satisfy. So we substitute them where x and y to see what exactly do we get. And that idea will help us to obtain the value for these constants, f, g, and e, c, by substituting these points to the cycle because they are satisfying the equation of the cycle. So case C, given points A, 1, 2, point B, that is 2, 5, and the point C, that is negative 3, 4. Now, we say now the points must satisfy the equation of the cycle if they are passed through by that cycle. Plus 2gx plus 2fy, plus c equals to 0. So we try to substitute them here where x and y. Now we can start it and say for point A, that is 1, 2, it means now this is x, this is what? Y. So we substitute them here. So we'll have 1 square 1, so we plus 2 square. Yeah, we plus now here, it will be 1, so it will be 2g. Then we plus this 2 times that 2, we get 4f. Now we plus c equals to 0. So you just get 2g, we plus 4f, we plus c. Then this will be 4, 5. It means when you take to the other side, it will be negative 5. So this now we can term it as equation number 1. Now for point B, which is 2, 5 again, we substitute the same thing that we have performed in stage 1 here. So x is 2, y is 5. So substituting them where x and y. So we get 2 square, we plus 5 square, we plus, now this is x, so here will be 4g, we plus 5 is y, so it will be 10f plus c equals to 0. So here we get 4g plus 10f plus c equals to what? So this will be 4 plus 25, we get 29, so it will be negative 29. If 0 minus this 29, we get negative 29. So this mark equation 2. Lastly, for point C. Now for C, which is negative 3, 4. Substituting them where x and y from the general equation of the cycle. So it will be negative 3 square plus 4 square. Then now because x is negative here, it will be minus 6g. Then we plus, because y is positive, we get 8f. Now we plus c equals to 0. So you'll end up getting negative 6g plus 8f. Now we plus c equals to what? Here it is 9. We plus 16, we get 25. So it will be negative 25. So from here, this makes equation number 3. Now we are going to solve algebraically. So on solving algebraically, then we have, let's see what we have. So we can express, maybe because we have three unknown G, F, and C, maybe we can express C in terms of G and F. So from equation 1, so here from equation 1, now which states 2G plus 4F plus C equals to -5. Now find the value of C will be -5 minus 2G minus 4F. Yes. So this we can term as equation 4. So now we say substituting equation 4 into equations 2 and 3. 2 and 3. So as to remain with two unknowns, and where now solving will be simple. So if we plug them here, it will be now 4G with plus 10F. Now with plus, it means we minus 5 this C here. We minus 2G, we minus 4F, now equals to -29. On operating the same, the like terms, 4G and this much we get 2G, 10F minus 4F we get positive 6F. Then here equals to -29. This now we plus 5. Yeah, because that's -5 is only the constant that we have here. So 2G with plus 6F equals to -24. On dividing by 2 at every time, we end up getting this way, equals to -12. So this will be maybe *1. So that will be *1. Now then we substitute that equation 4 into 3, into here 3, to have a new equation that will be *2 with only two unknown, G and F. So also, we say also here, now coming to here, -6G, when we plus 8F, we plus C now, that is -5 minus 2G minus 4F is less more to -25. So operating the like terms here, -6G minus 2, we get this -8G. 8F minus 4, this will be positive 4F. And then now equals to -25, we plug that 5, constant, numerical terms. So here we end up getting negative this much, plus 4F is less more to -20. So if we divide by 4, because 4 now will be common at every term here, will be the common factor. So if we divide by -4, so we end up getting here 2G with minus F equals to 5 positive, because -20 divided by -4, it is 5 positive. So that is how now we get. So this, now we label it as *2. Now on solving algebraically again, *1 and 2, what exactly do we have? So you remember equation 4, C. So that's very important. So now we say, on solving algebraically, equations *1 and the *2. Yeah, then we have, what exactly do we have? So we have G plus 3F less more to -12, and 2G minus F is less more to 5. So here we can try to solve maybe by elimination method. If we use elimination method, we are trying maybe to eliminate G, solving for F. So we say eliminating G, solving for F. Solving for F. So if that to be the case, and the 2G now minus F equals to 5 here. So here is one. We go there for a term that is eliminated. We take the zigzag assignation of the coefficients. So here is 2. So this will be 2g plus 6f. We times all, negative 24. Here it is 2g minus f equals to 5. So now I'm subtracting because the condition obeyed that we have uh, the same coefficient and the same sign, so we apply negative operator, minus operator. So this now will be eliminated. Now this here will be 7f, less more 2. Negative 24 minus 5, we get negative 29. So the value of f here becomes negative 29 over 7. Again, coming to eliminate, so we say eliminating. Now f solving for g, solving for g. So we go back again here. That g, we plot 3f less more to negative 12, then 2g minus f less more to 5. Then now, if we are dealing with f, now we take the zigzag assignation of these coefficients. So here we drop it here, and here we drop it there. So on multiplying, we get negative g minus 3f equals to 12 positive. Then here we get what? 60g minus 3f less more to 15. So we look for f now. What sign should be, what operator should be applied here? So if the coefficients for f to be 0, it means here we need to introduce negative because the sign look the same. So this minus that, we get negative 7g. If that to be the case, then this now becomes 0. 12 minus that much, we get negative 3. If you divide both sides by negative 7 here, we end up getting the value of g is less more to 3 over 7, positive values. Now, after getting g and f, we go back here and we find the value of c, the constant c. So the constant c from equation 4 that we assign it to be equation 4, then from equation 4, which is that c is less more to negative 5 minus 2g minus 4f. Now we say g, it is now known, it is 3 over 7, and the f, it is negative 29 over 7 here. So now we plug them where they're supposed to be in that equation 4 to obtain the value of constancy. So on substituting now here, so c is less more to negative 5 minus 2 brackets, g, that is 3 over 7, minus 4, the value of f is negative 29 over 7. Now on operating, we get minus 6 over 7, we plus. Now this 29 times 4. So we get 36, 3 here is 8, so 11. 1160 over 7. So on operating now, the LCM here we know of 177 will be 7. So here will be 7, or you can use the non-programmable scientific calculator to simplify. But here if we go manually, this will be 7 times this negative 35, we minus 60, we plus 116. So on operating now, here will be negative 41. Now we take 160, we minus that 41. So we get 5. So here it will be 5 and here it will be 7. So we end up getting positive 75 over 7. That will be the value of the constancy. So if that will be the case, we go back to that general equation of a cycle now. Now the general equation of a cycle, x squared plus y squared plus 2 here, 2gx plus 2fy now plus c equals to 0. So we plug those constants, x plus y squared. Now the value of g here, it is 3 over 7. So we plus, now 2 times 3 over 7 will be 6 over 7x. Now f, it is negative, so here will be minus 2 times 29 will be 58. 58, then y over 7. And now the value of c is positive. Then we plus 75 over 7. equals to 0. So from there, it means now we have tried to write the equation of the cycle in that form as guided from the question. And up to that point, we are through with part D. So now let's proceed to see now part D. So now when dealing with part D, that is what is the length of the tangent line from the point 6, 2 to a cycle with the center that much 2, 1 and the radius of 2. So what is needed here, it is just the length of that tangent line from a point now to the center of a cycle. So case D is the matter of distance formula. That's imagine made, this is a cycle, this is our cycle, and here we have a tangent line, and here it is the center of a cycle where now it is known it is 2, 1 here. So we need to find the length of this tangent line provided from the point, the tangent line is from the point 6, 2. And we are told that the radius of a cycle is 2. So we know the radius is perpendicular to the point of tangents here. If the radius and the tangent line, they are perpendicular. So the radius here is 2 units. And here we can say the point of tangents. So what is the length of the tangent? So here is what is needed now. So we can term here is the length of the what? Of the tangents. If considering this A, the point of tangents, and this is the point that is outside of the cycle where it is passed through by the tangent line. And here it's the center of a cycle. So maybe now we can term that this point maybe to be point B here, whereby it is 6, 2. So what is needed now? The length of a cycle. So we can go even from Pythagoras theorem. Pythagoras theorem can work here, that we have r, the radius, we have the length of the tangents, and this can be found because we have 2 points there. The distance formula can be used. So if we find the distance OB, that means will be the square root through the distance formula, 6 minus 2 bracket square, we plus that 2 minus 1 bracket square. So here we end up getting, it will be 4 square, now we plus 1 square. So it will be 16 plus 1. So we'll get a radical of 17 units. So that will be OB, the length of OB. Now, from Pythagoras theorem, because here we have right angle triangle due to radius, the line this represents radius of a cycle is perpendicular to the tangent line at the point of tangents. So from Pythagoras theorem, that r square, if we plus L square, equals to OB, the length of line segment OB square. Now, what we are in need of here is L square. So L square is OB square minus R square. So in proceeding, L square equals to what? Or we can say L equals to the root of that OB square, then we minus R square. So here we end up getting OB, we know it is the root of radical of 17. So we put square minus R, it is 2 units, that will be 2 square. So here we end up getting, on simplifying this, it means we get 17 minus 4. So we get the root of 13. So that will be the length of a cycle. So now we conclude and say the length of tangents from the point here, the length of tangent from the point, from what point? From the point 6, 2 to the cycle, with center. The center is 2, 1, and the radius of 2 units is the root radical of 13 units. That will be the length of the tangent line. So that is case D. Now let's see case E. In case E, we are provided with the information that sketch the ellipse having these characteristics. A central ellipse, when we say the central ellipse, it means the center of that ellipse. So here the detail, the center of that ellipse is the origin, 0, 0. And the other characteristics, we are provided with the foci. It means here we have two focus. The foci, that's the plural for focus. So that here we have two focus. That is positive or minus 4, 0. So foci is provided here. The foci, that is positive or minus 4, 0. It means one is 4, 0 and the other one is negative 4, 0. So this represents like saying positive or minus AE, 0. It means here changes are made on x coordinate because the directions line are parallel to y-axis. So you need to be smart on those properties. When directions line are parallel to y-axis in that ellipse, it means the changes have to be made on the x coordinate. And that's why here we have positive or minus 4, 0. It means here was positive or minus AE, 0. That E represents eccentricity. And normally in ellipse, eccentricity is less than 1. So the other property that we are provided is the vertices. So they have to be 2 because we are talking about conic ellipse, the vertices. So here it is positive or minus 5, 0. That represents positive or minus A, 0. Yes. So if that to be the case, now we are told just sketching, just the sketching. So let's see how we can draw. And remind you, remember that if changes are made on the x coordinate, because the x line is parallel to y-axis, it means that ellipse, its major axis is along the x-axis. Its major axis is along the x-axis. It means it bulges on the x-axis. So it is very narrower to the y-axis. Narrower means very thin to this y-axis, but very wide along the x-axis. That's the meaning of bulging. So now always the graph of ellipse is drawn on the xy plane. So we can design like this x-axis, and this is y. So this is the origin. And then now here the units 1, maybe 2, 3, 4, 5, maybe 6. So -1, -2, -3, maybe -4, -5, and so forth. And here we have just 1, maybe 2, here 3, here is 4. Here is -1, -2, and -3, maybe -4. Now the other thing that we need to know here, if it is now we have understood that through changes on x coordinate here, that the x line is parallel to y-axis, that's why changes are made on x coordinate. It means we need to know also how about the minor axis, which is always determined through the value of constant b from the ellipse concept. That is ellipse we know here, we plus y square here over b square equals to 1. So if it is along the x-axis, it means a is greater than what? Than b. A is greater than b. And if that to be the case, it means b square equals to a square. Then here we have that's ae, 1 minus ae. Yeah, it looks this way. So you can just find the value of b from here, the value of b from there. So yes, sorry, here is because it's less than 1, AE minus 1. Yes. So if we try to find here, it means we'll end up getting the value of B is what? Is 3. Because if we compare this one and that one, A will be 5, so here will be 25. So it will be 25. The value of AE here will be 4. 4 minus 1 here is 3. Yes, and if here is 25, 25 now times this 3 here. So we'll end up getting something like the value of B. If we try to find out, because A there is greater than B, it means that ellipse, this is ellipse along x-axis. So if B, if A, if you compare here A, we know here our A here will be 5, and now B here will be 3. Yes. So if we design here, so B represented the minor axis. Now A represented along the x-axis, the major axis. So now the foci and the vertex. The vertex are the one that we consider. So it will just go this way along 3 there. Then we go until we reach 5 again. Then negative 3. Sorry, here. Then we go to 5. So it means now this will be the ellipse that we are talking about. So that will be now the conic ellipse. So as you can see here, the distance from here to here, that is positive B, negative B, and now A will be 5 positive, yes, and now the foci are around here. So that is foci, and that is another focus, S prime. So this is negative 4, 0, and here is 4 positive, 0. And these are the vertices, 5, 0, negative 5, 0. So these are, it's just a sketch of an ellipse, as you can see. And up to that point, we are through with that question number 8, appeared in the year 2025. Thank you very much.